Hello everyone. In this lecture, we are going to see something about supercharging. Now, what do we mean by supercharging? We have already studied in case of SI and CI engines the conditions required for proper ignition and proper combustion of fuel. As far as SI engine is concerned, if the temperature and pressure at the start of combustion is on the higher side, then this might lead to pre-ignition, or in other case, this might lead to the charge being ignited before the flame reaches and consumes it. This will ultimately result in detonation and knocking. However, in case of a CI engine, if the pressure and temperature of the air which is coming inside the combustion chamber is on the higher side, then this will ultimately result in a shorter ignition delay, which in turn will lead to a reduced possibility of detonation and knocking. So basically, a supercharging method includes the concept of increasing the pressure of the incoming air. If in case of a SI engine, if we increase the pressure of incoming air, along with pressure, its temperature will also increase, and this might lead to a very short ignition delay, which might further lead to knocking. Very short ignition delay, which will lead to knocking. However, in case of a CI engine, if the ignition delay is smaller, this will lead to a reduction in knocking. So supercharging concept basically involves the increase of pressure of the incoming air. As far as the definition goes, supercharger is an equipment that compresses the air which is being delivered to the engine, which in turn allows the combustion chamber to be filled without enlarging the space to a greater capacity. As air is compressed, more amount of air can be accommodated into the limited capacity of the combustion chamber without any change in it. In short, the purpose will be to increase the power output of the engine. The purpose of supercharging will be to increase the power output of the engine. Since it accommodates a larger quantity of air in same amount of space, then the volumetric efficiency of the engine will increase than in case of a normally aspirated engine. That is an engine which is taking in the air at normal atmospheric conditions of pressure. We say that supercharging is achieved by supplying air in case of CI engine, or if we are considering a SI engine, an air fuel mixture which is pre-compressed before delivering to the combustion chamber, so that the pressure is higher than the pressure at which the engine, both SI and CI, will naturally take in air or the air fuel mixture. Supercharging may also be called as boosting, as this will help to increase the power output of the engine, or we can say it will help to boost the power output of the engine. Hence, in other words, it can be called as boosting. Now, let us go on a bit further. What are the basic objectives? We say that supercharging is done, as we already discussed, to induct more amount of air by compressing it into the same space of the combustion chamber. If more amount of air is inducted, more amount of fuel will be burnt, and if more amount of fuel is burnt, this will in turn lead to a larger power output. In summary, we can say that following are the objectives of supercharging. That for a given weight and bulk of the engine, that is by keeping the engine same, by keeping the cc, okay, the cubic capacity, the volume of the combustion chamber same, supercharging will increase, or it should increase the power output. As far as applications are concerned, this is an important factor in case of an aircraft, marine and automotive engines. where weight and space are of prime importance. You have to consider the weight of the engine and the space in which it is to be accommodated, and at the same time you have to work towards increasing the power output. So by keeping a tab or by keeping a check on the weight and the space of the engine which is allowed, supercharging, that is compressing the air or the air fuel mixture before delivering to the combustion chamber, might lead towards increased power output. Again, if the power output is to be increased, then a better performance from the engine is expected. And also, to compensate for the loss of power due to high altitudes for aircraft engines, supercharging is very useful. Okay, now let us go on a bit further once again. What is the principle? What are the concept involved? As you can see, more fuel, when it is mixed with more amount of air, it will ultimately result in a greater amount of heat release rate. That is, in one single word, a bigger explosion at the time of combustion. The bigger the explosion, the higher will be the rate of pressure release from the combustion of the fuel. The higher the amount of rate of pressure release, the more amount of force will be exerted on the piston, which will be moving in a downward direction in the expansion or power stroke. And when this happens, a greater amount of horsepower is derived out of the existing engine. There are certain points that we need to consider, that we cannot simply pump more fuel into the engine. This will distort the air fuel mixture. If it becomes too rich, we already know from the air fuel mixture requirements of engines that it will be hard to burn. It will be very difficult to combust a mixture which is very rich. Therefore, the chemically correct mixture, that is 14 is to 1 of air fuel, it is essential for the engine to operate perfectly. Further, we see that supercharging provides more amount of air by compressing it above atmospheric pressure. As a result, this will provide more fuel into the charge and also provide in turn for a more powerful explosion, thereby giving you an increased power output, torque and speed from the same engine. There are certain advantages and disadvantages which are associated with supercharging. First, let us look at the advantages. The power output of the engine is increased, as we have already seen the reason behind it. Then more quantity of charge can be induced into the engine cylinder. Why is this? Because air will be compressed or the charge will be compressed as a result in the same capacity of the combustion chamber. Because the charge or the air is compressed, a larger density of it can be accommodated. Then better automation of fuel is possible. Why is this? Because let us consider the fuel will be at atmospheric pressure, and air, when it is compressed to a higher degree which is greater than the atmospheric pressure, then the pressure head between the compressed air and the fuel which is at atmospheric pressure will be higher. As a result, the expansion process of the fuel will be more efficient, and when the expansion is more efficient, it will be easily converted into atomized particles. And when the fuel is atomized properly, better mixing of air and fuel can be obtained. This is the next advantage. Once again, better scavenging of exhaust gases is possible. Scavenging means removal of exhaust gases from the previous cycle to make room and to make possibility of better chances of combustion in the next cycle. If compressed air is inducted into the combustion chamber, then this high pressure air will make the exhaust gases from the previous cycle move out of the combustion chamber in a more effective manner. Then again, as the power output increases, the torque will be improved for the total speed range of the engine, and also for a lower speed of the engine operating, it will give you a better torque. Then again, acceleration of the engine is vastly improved because air fuel mixture becomes more homogeneous, and since it is compressed, it will burn at a higher rate and thereby release a greater rate of pressure release and heat. Hence acceleration will be better. Then also the SFC, that is the specific fuel consumption in a supercharged engine, is a little bit lower. Also, mechanical efficiency and combustion efficiency is expected to be improved. And in case of a CI engine, exhaust smoke is reduced. This methodology cannot simply have only advantages. It has to have some or the other disadvantages, which can be enumerated as detonation tendency will increase in SI engine, as we have already discussed right at the start of this lecture. Then heat losses due to turbulence and thermal stresses will be more. Also, the valve overlap period, that is the time or the crank angle degrees for which both inlet and exhaust valve remain partially open, will increase, and it may go up to 160 degrees of crank angle rotation. Also, when the power output is increased, when the acceleration is improved, when the torque even at lower speed is improved, then this will demand a better cooling and lubrication. So this might be a disadvantage if it is not provided properly, and also this will increase the cost of the engine. So this was some information about supercharging, its advantages, disadvantages, objectives, and its principle of operation. Okay. Thank you very much.